Hello and welcome to your mathematics class. Today we will start mathematics from chapter 2, that is algebra. And in algebra we have two parts. First part deals with matrices and the second part deals with determinants. So we will first start with matrices. Now what is a matrix? Matrices is plural, singular singular is matrix. Singular is matrix, plural is matrices. What is a matrix? Matrix is a systematic collection of numbers or functions in an orderly fashion that represent some particular data, and these matrix can be used for algebraic manipulations, for example addition, multiplication, subtraction, etc. So let us first define what is a matrix. Matrix is a systematic collection of numbers or functions in an orderly fashion, that represents a particular set of data, or you can say information, and is fit for various mathematical or algebraic operations. That's how we define a matrix. Now let us see how a data can be represented in matrix form. Let me first give an example of a data. For example, let's say in your college, in class 11, we have 13 boys and 16 girls, and in class 12 you have 17 boys and 20 girls. So if I say this is the data D, suppose, I can represent the same data in matrix form like this: D equals 13, 16, 17, 20. So that comes under matrix representation. So throughout this chapter we will be dealing with several types of matrices that represent several types of data. Now let's move on to the next part. Representation of matrices. How do we normally represent a matrix? A matrix is normally represented with a capital letter of the alphabet, maybe A, capital B, capital C, capital E, any alphabet from the English alphabet, and it is either represented with this type of braces, single bracket braces, or it can be represented using this type of braces. However, this type of brace is more preferred. So in your book or in your syllabus we use this type of braces. We will not be using this type of braces. Okay, so let us say we make a matrix consisting of some numbers. Let us say this is a matrix 1, 2, 3, 4. So within this representation we have some numbers in an orderly fashion. We call this as the elements of a matrix. These are known as elements. 1 is also an element, 2 is also an element. Elements or entries of a matrix. Entries of matrix. Fine. So 1 is an element of this matrix A, 2 is an element of this matrix A. Similarly 3 and 4 are also elements of the same matrix A. Now let us recognize some properties or some characteristic features of any matrix. Let us say this is 1, 2, 3, 4. We can see readily that this is one specific array of this matrix. We call this array of numbers as a row. This is known as a row. This is another row. This is also a row. So let us say this is the row 1. We call this row 2. Again, we see that another array exists in the vertical fashion. We call this as a column. We call this as a column, say column 1. This is also another column. We call this column 2. So we see that this matrix A has 2 rows and 2 columns. So rows are in horizontal pattern and columns are in vertical pattern. Rows start numbering from the upward position, from this top position, and goes downwards. Row 1, row 2. Similarly, columns numbering starts from the left side. Column 1, column 2. So that's how we represent the columns and rows of any matrix. Now this is clear to you, the rows and columns of any matrix. Now let us see if you can find out how many rows and how many columns does this matrix have. For example, let us say we have a matrix 1, 3, 7. This is a matrix. So can you guess how many rows and how many columns does this matrix have? Obviously this is the first row, so we say this is row 1. This is the second row, row 2. This is the third row, row 3. And how many columns does this have? Only one column exists in the vertical fashion, so you say this is the column 1. So this matrix has 3 rows and 1 column. Let us give you another example. 5, 7, 3, 2, 8, 9. Can you guess how many rows and how many columns does this matrix have? Obviously this is the first row, so this is row 1, and this is the second row, this is the row 2. And how many columns does this have? This is the first column, next second column, next third column. So this matrix have 2 rows and 3 columns. Similarly, another example, 1, 3, 7, 9. Obviously this has 2 rows and 2 columns. How many rows and columns does this matrix have? It has only 1 row and 1 column. Now it must be clear to you now. Let's move on to the next topic in matrix. We call it order of a matrix. Any matrix has its own order. Let us say we have a matrix 1, 3, 7, 2, 9, 8. This is a typical matrix. How many rows does this have? This matrix has 2 rows. First row, second row, 2 rows. And how many columns? first column, second column, third column. So this has 3 columns. And we represent the order of a matrix by number of rows by number of columns. This is known as the order of a matrix, and we normally write the order in this position. So this is having 2 rows and 3 columns, so we will write 2 by 3 matrix. So this is the matrix 1 3 7 2 9 8, and 2 by 3 is the order of this matrix. Let me give you another example. Suppose we have a matrix 1 7 8 2 9 7 3 8 10. This is one typical matrix. How many rows does this have? Remember, it is R by C. So how many rows? 3 rows. First row, second row, third row. How many columns? First column, second column, third column. So this is typically, this is R, this is C. So R by C representation is for the order of a matrix. Another example, 1 2. What is the order of this matrix? This is 1 row and 2 columns. Very good. How many, what is the order of this matrix? First row, second row, 2 rows by how many columns? Only 1 column exists, so its order is 2 by 1. Another example, 5 6 2 1 0 9. How many rows? First row, second row, 2. How many columns? First column, second column, third column, 2 by 3. Another example, 1 0 5 9 2 7. How many rows? First row, second row, third row, 3. How many columns? First column, second column, 3 by 2. So these numbers here represent the order of a matrix. Let's move on to the next topic. Now let's discuss about the various types of matrix that can be existing. So main heading is types of matrices. There are some special types of matrices. The first type is the column matrix. We call it a column matrix. Why do we call it a column matrix? Because it consists of only 1 column only. So a column matrix looks like this: 1 3 5. It can have as many number of rows as possible, but the main characteristic feature of a column matrix is that it has only 1 column always. So here the order of this matrix is 3 by 1. Remember, it is R by C, so C is always 1 here. This is another example of a column matrix. This is a 2 by 1 matrix, another column matrix. This is another column matrix, 5 6 9 8. It is a 4 by 1 matrix, another column matrix. So column matrix is a matrix which is only 1 column available. That's a column matrix. Now we are clear about column matrix. Let's move on to row matrix. Similarly, there is a row matrix available. So obviously row matrix is a matrix which consists of only 1 row. For example, 1 3 5. It can have as many number of columns as possible, but one thing that is certain, that is fixed, is that it will always contain only 1 row. So what is the order of this matrix? 1 by 3. Another row matrix is 1 9. It is a 1 by 2 matrix. So this is another row matrix. So these are all row matrices. This is also a row matrix, 1 2 3 4. This is a 1 by 4 matrix. always remember the order. It is always R by C, R by C, R by C, R by C. So here R is always 1, 1. Here it is a column matrix, so it is C, its C value will always be equal to 1. Here R value will always be equal to 1 because it's a row matrix. Then we have other types of matrix. We can have any row, any column type of matrix. That means, for example, 2 5 0 7 3 9. So here number of rows is 3, number of columns is 2. So it can have any number of rows, any number of columns, no problem in that. However, there is a special type in this. We call it a square matrix. We call it a square matrix. Now this is the most important topic in the chapter because most of the theorems, most of the problems will be from square matrix. A square matrix is a matrix whose number of rows equals the number of columns. This is the most important feature of a square matrix. So let me rub it out and show you what a square matrix looks like. Important. Square matrix is a matrix whose number of rows equal to the number of columns. So this is a square matrix 1 2 3 4. So it is obviously a 2 by 2 matrix. See, the number of rows here is 2, number of columns is 2, so 2 by 2. So this is a square matrix of order 2 by 2 or simply 2 because number of rows is same as number of columns. So the 2 feature is common in both rows and columns. So we say this is a square matrix of order 2 or 2 by 2, whatever you choose. This is a square matrix of order 3. See, there are 3 columns and 3 rows. So 3 rows, 3 columns. So a square matrix of order 3. Similarly, I can go for square matrix of order 4, square matrix of order 5, and so on, so on. Now, square matrix, in square matrix there are some special category. We call it the first special case. We call it a special case of a square matrix. We call this case as a diagonal matrix. Diagonal matrix. So obviously diagonal matrix is a square matrix, but it has certain characteristic feature which is unavailable in other types, and that is that in a diagonal matrix the non-zero elements will be present in the diagonal. This is known as the diagonal. In a square matrix, this is known as the diagonal. All square matrices have a diagonal. In this square matrix, this is a square matrix obviously because number of rows here is 3, number of columns is also 3, and the diagonal element is 1. Diagonal elements are 1, 3 and 5. And what are the all off diagonal elements? That means the elements outside the diagonal are always 0. So such matrix is known as a diagonal matrix. It is a square matrix, but it is special because the elements outside the diagonal are always 0. So this is a diagonal matrix of order 3. Another example of a diagonal matrix is 1 0 0 9. This is a 2 by 2 diagonal matrix. Similarly, I can go for other order diagonal matrices. Now in diagonal matrix there is a special type. We call it a scalar matrix. Diagonal matrix is a special case. We call it a scalar matrix. We will rub it out and see what is the scalar matrix. Scalar matrix is obviously a diagonal matrix, but in this diagonal matrix all the elements in the diagonal are same. See, the diagonal elements are same here. 5 is the common diagonal element. So this is obviously a 3 by 3 square matrix, and it's also a diagonal matrix because all the elements are 0 outside the diagonal, and it's also a scalar matrix because the diagonal elements are all the same. This is another diagonal matrix, square root 3, 0, 0, square root 3, because the diagonal here is the same, square root 3, a 2 by 2, 2 by 2 scalar matrix. Now scalar matrix has a special case again. It has a special case, and we call it an identity matrix. And it is also very important. What happens in an identity matrix is that the diagonal elements are all the same and it is equal to 1. So diagonal elements are all 1. Such a matrix is known as an identity matrix, and it is represented with a special alphabet, capital I. Capital I is used to represent an identity matrix. So throughout the chapter we will be using identity matrix in several places. So this is a very important matrix. It is obviously a 2 by 2. Another 3 by 3 identity matrix looks like this. See, the diagonal elements, they are all same and it is equal to 1. So this is a special identity matrix, is a special case of a scalar matrix. And there is a last type of matrix, we call it a zero matrix. Can you guess why is it known as a zero matrix? It is because all the elements of a zero matrix are 0. Whatever order it may be, all elements are 0. So it is a 3 by 3 matrix, and we represent this zero matrix with a capital O. Capital O, the alphabet capital O represents the zero matrix. So this is a 3 by 3 zero matrix. Another example of a 2 by 2 zero matrix is this. Now it must be clear to you the several types of matrices that we have discussed up till now. Next topic, let's move on to the next topic, and we will be doing some examples. Next topic is equality of matrices. Equality of matrices. Two matrices will always be equal if and only if, suppose there is a matrix A and there is another matrix B. These two matrices are said to be equal if they meet certain conditions. First condition is that they must be of the same order. They must be of the same order. That means they must have the same row by column, row by column. That means number of rows equal to the number of rows in B. Number of rows in A, number of rows in B, same. Number of columns in A should be equal to the number of columns in B. And the second condition is that corresponding elements of both matrices must be same. So these are the two conditions for two matrices to be equal to each other. That means, first of all, the first condition is that they must be of the same order. The order of A must be the same as the order of B, and each and every element of A should be equal to each and every corresponding element of B. Let us see what it means. For example, this matrix 1 2 0 5 is the same as 1 2 0 5 because its order is a 2 by 2, its order is 2 by 2, and each and every element is same to same. that's why we can call this matrix is equal to this matrix. However, we cannot say these two matrices can be equal. For example, a matrix 1 2 is not equal to 1 2. Reason is that it has how many rows? 2 rows, 1 column. How many rows? 1 row and 2 columns. See, the order is not the same. Here it is 2 by 1, here it is 1 by 2. So these two matrices cannot be equal. So that's why we cannot say these two matrices are equal. In a similar fashion, these two matrices cannot be said equal. 1 2 0 5 is not equal to 1 2. The reason is that this is a 2 by 2 matrix and this is a 1 by 2 matrix. See, the order is not the same. So this is the condition of equality of matrices, and we will be solving some problems. Let us say we have a question. Write down a question. Question is, if matrix A is given as A plus B, B plus C, C minus B and B minus A, and matrix B